So there's a couple principles just to keep in mind with respect to the time in your model. Within your model will be various quantities that depend on time. When I say depend on time, I mean dimensionally they are defined in a way that means they depend on the time units, the units by which you're measuring time. So for example, if we have a length of childhood expressed, that's a time, a quantity that measures some duration of time. So it's going to have a dimension associated with it. We could write it this way, or the dimension of this variable, length of childhood, call it L, is time. Okay. The dimension associated with time. And when we have a quantity that's dimensionally refers to time, we'll have associated units with it. So this might be measured, for example, in days, might be measured in years, etc. Similarly, you may have other quantities which are not directly times, but which are dimensionally dependent upon time. A classic quantity would be something like chance per unit time of recovering from infection, something like that. So this might be a coefficient, alpha for recovering from infection. So maybe you have a state chart, S, and then you have I for infection, and then you have R here, and you have a certain chance per unit time of going from I, maybe it's set by alpha, and this dimensionally would be, if this is a chance per unit time, what's its dimension? 1 over t. Yeah. And so this would be represented as, and by the way, you can interpret this 1 over t as like a chance per unit time, right? It's a density. So if we want to describe its associated units, to quantify it, it would be, a chance per day, for example, right? Or a chance per year, or something like that, right? But there may be other things too. There may be another constant that's, for immigration, call it M, which is measured in persons per year. This would be a dimension, person per time. And its unit might be, particular persons, person per day. But it might be measured in other units. It could be person per year, right? Be another thing. It could be in thousands of persons per day, something like that. So 3 in the numerator, goes 3. Maybe it will be 3,000 people per year, for example. Okay. We could choose our units. So when we have quantities in our model, which are dependent on time in this sort of way, and we'll be talking through what these things mean in the future, in those future lectures. When we have this, it's very, very important we be clear about what these units are associated with all the quantities. Because a 3 or a 5 or a 0.1 is meaningless in and of itself. It means something only when we associate with a particular appropriate dimension. It could be measuring days. It could be measuring years. It might be what we call dimensionless, in which case it's something like a fraction. Again, I argued like the fraction of this room covered by chairs. It's a dimensionless quantity. It doesn't matter if we measure the floor of this room and the furniture in square meters or square feet or what have you. A certain fraction of this room is covered by furniture no matter what unit we measure it in. It's invariant as to measure. But these quantities here, ladies and gentlemen, so we have some quantities which are invariant to measure. Maybe this would be, I don't know, I'll call it F for floor area covered, fraction of floor area covered. This would be a unit dimension. Okay, unit dimension. People will say dimensionless, but it's no more true than you say like something of 0 length is lengthless. It has a length at 0. This has a dimension. It's unit dimension. Now, the difference between a unit dimension and all these guys up top, which have these very particular dimensions, is that something of unit dimension doesn't care about your units. You can change your units willy-nilly for this guy. You could change measuring time and days to years, and this thing is not going to change. You could change it from measuring people and thousands of people versus individual people. It doesn't matter. You can measure things like Canadian currency amounts or U.S. currency amounts. It doesn't change. This sort of quantity is invariant as unit change. These quantities up here, because they depend on time, they will change when you change your units in your model, when you wish to express them in different units. So something of that's measured like a length of time. Suppose that I had that in years, 5 years, duration of childhood, and I want to express it in days. How do I convert? 5 years would be how many days? Give me the formula. Yeah, multiplied by the number of days in a year. How about for this guy? How do I have a chance per unit time? How do I convert? Convert from years, something measured in, or using years, to something measured in days. So in other words, we're switching from a situation where our time is quantified in years to where our time is quantified in days. How would I switch something of that's a chance per unit time? I would do a what? You heard it. So suppose I have, on a per year basis, 0.1 chance of, having some horrible thing happen. Sorry, my imagination is very good. 0.1 chance of
winning the lottery. Let's be positive.
Okay, winning the lottery per year. What's my daily chance of winning the lottery? Formula?
Times multiplied by the inverse.
Good. Excellent. And why inverse? Well, the dimension actually associated with these things tells us what we have to do, okay? So here we're going to be multiplying by 1 over days per year. Here we're multiplying times days per year. Now, when you have these quantities in your model, you can have model quantities which are expressed in years, some expressed in days per convenience. But what's very important is that AnyLogic's mechanisms, the actual descriptions of the processes you capture in state charts or stocks and flows or events, transitions, all of those things need to be specified in consistent time units. And where, ladies and gentlemen, are the time units associated with a model and AnyLogic specified? Where can you actually tell it in what units you are, where can you be explicit about saying what units I'm measuring time? It is in the...
Isn't there an extra field for parameters and any other?
Well, yes, it does allow you to specify units, but oh, I shouldn't be showing you that. Sorry. Moving right along. Okay. So well, I have to create solutions, so I know if what I'm telling you is doable. So here, associated with the model as a whole are things you could actually say what the time units are. Now, this is a convenience. This is actually not something which is deeply important in the sense. What is important is that you be consistent when you tell AnyLogic mechanisms of the times or the rates that you use a consistent unit. Okay. What's very important is that when you have a timeout, if you're measuring that timeout in years, that when you have a rate, a chance per unit time, that be measured in 1 over a year. Okay, that is A1 important. Similarly, if you have, a situation where you have an event going off with a certain cyclic period between event firings, that has to be measured consistently too. So it will be years. That's the important thing, ladies and gentlemen, that you specify in a consistent fashion to AnyLogic using some units. What's not as important, but which is a convenience, is that AnyLogic allows you to say what the time units are in this model. Now, you could bamboozle it. You could hornswaggle it. You could trick it by using using years in your model, and you tell it it's days. You say, I'm using days, AnyLogic, and you're actually using years. It doesn't know the difference. But what this is a convenience, because if you ask it, what day is it now? You know, if you're using its calendar functions, and you say, what's the current day? And you say, I want to open my clinic at 7 a.m. Monday, or something like that. It'll be using the schedule based on the time units you specify. But fundamentally, that's not a constraint. You could ignore that as long as you're not using its calendar functions and so on. You could ignore that and say, you know, you might not even know this is here, and you just measure things in years. And as long as you're consistent, that's fine. As long as you're not using the functions which depend directly on this, which are things like what day of the week is it currently, or what time of the day is it, and that sort of thing. So when you are speaking to AnyLogic's mechanisms, you need to be consistent. So let's suppose that you want to be consistent. You're standardizing your model in terms of the underlying unit of time in terms of years. Okay. So now suppose you have a rate alpha that's measured in 1 over a year. Now maybe you have another thing that you find more convenient to think about in terms of days. Okay. You can express this other quantity in terms of days. That's fine. But when it comes to interface with this guy here, so maybe you have a model parameter that's, you know, mean days infectious or something like that. So that gives the number of days I stay infected, right, before I recover. That's fine. There's no unit police that it's going to say, you know, this is banned that you have days. That's perfectly fine. But what's important is that you not in the rate give 1 over this mean days infectious. That would be inconsistent, because now where the rubber meets the road is in this specification of things like rates and timeouts and time between events. That's where the rubber meets the road. AnyLogic expects a consistent set of units. If you want to use the days, that's fine. What you would need to do is you could do it as far as I'm concerned improperly and crudely, or you could do it well, prettily, with elegance and beauty, as befits dignity as software engineers. The way to do this crudely would be to have in the rate specification, you would have, if this is a mean days infectious, and we are specifying a rate, and the underlying unit of the model is years, how would I go from this to, so if I want to use this in my calculation in a crude way, what would I need to do to turn this into if I have a sort of, I want to have a rate which yields something whose mean time in this state is this number of days. How would I do that? Well, I'd first convert this into years. So I'd have this mean days infectious, call it MTI, and I could divide it by 365.2524, is it? Something like that. You guys don't have to put that all in there. And then I would need to, so that's the mean years I stay infectious, and then I could take 1 over that, right? And that would be the rate such that I'd stay infectious for this number of days or this number of years, right? I could do that. Alternatively, as befits your dignity as software engineers, you could have another variable that's mean years infectious that depends on this and divides it by this is the key thing, days per year that's expressed as a variable or parameter, probably a variable, days per year. And so you have this explicitly, instead of putting this as a constant into your model, as a magic number that appears in your model somewhere, or many places. You have a single variable that encodes that, and I would have a mean years infectious, and this would be 1 over mean years infectious. That, ladies and gentlemen, is the more robust way, because this, when people are tired, as I am right now, and they look at this, there's going to be a lag of time before they parse what this is. If you have it as 1 over mean years infectious, it is more transparent. It is more clear. It is more clean. And it would elevate my sense of your skills in the software engineering area. But ultimately, this course is not per se a software engineering course, so I won't enact penalties, exact penalties upon it for use of this sort of mechanism. Yes.
So AnyLogic supports specifying units for numbers and parameters.
Correct.
Does that play into this at all? Does it have any sort of, I guess, if you will, type checking along those lines?
Yes, it does. And we will get to that issue in this further parameter. So let's go see if I can call up a just a parameter here. There's this whole use units. So what basically that will give? There are certain things it will give, certain things it won't give. Okay. So what Alex is alluding to is something that's very germane to the coming lectures, which is in a way that's a little bit similar to types within type systems within programs. There's a semantics associated with dimensional quantities, okay? And that semantics is strict in the sense that we cannot expect sensible results if we're doing certain things that dimensionally are insensible. For example, if we add something of dimension time to something to another quantity, maybe it's 1 day, and we add it to something that's of dimension 1 over time, we add it to something that's 1 over days, it is semantically meaningless. It means nothing. So we may add 1 to 2, and we get a numerical value of 3, but that 3 is worthless. That computation has no meaning semantically. We're getting out a number that really doesn't make sense. It doesn't describe anything meaningful. Similar if we add a person to a time. 1 person plus 2 years is 3 what? It doesn't make sense. It doesn't add up. That's the deep issue, the semantics. There's an issue that is still a problem, still meaningly useless, numerically silly and useless, but is getting warmer in terms of potential, which is when you do something like add a days to a years. 2 days plus 3 years is what? Well, that question can actually be answered. It's just that Java isn't smart enough, and AnyLogic isn't smart enough to do that automatically for you. But what it can do is detect it. So if you're adding a 2 days to 3 years, it will actually say this is bad news. You gotta switch the units for one of them so that you're adding commensurate units.
So it's like a type check.
It's like a type check, roughly. If you run the program, you do so at your own peril, and you'll get out nonsense. But it will warn you that you have to correct it. If you're doing something like adding person to person over time, you're broken in a more, well, I shouldn't say that way, sorry. Your formulation is broken in a more fundamental sort of way. By the way, people do this all the time. One of the biggest problems in system dynamics modeling is you have a stock, X, and a flow, F, and people try to add them together. Stock plus the flow, or maybe they take the stock minus the flow. Like, oh, I want to see, when the flow comes out, how much is left. Why is that bad? Why do I say that's ill-conceived? Why do I say it's meaningless semantically? What's the unit of the stock? Let's suppose the unit of the stock is, call it
you know, the unit of the stock is A. The dimension of the stock is A. What's the dimension of the flow? Oh, good. The dimension of the flow will be A over some time unit. Why does it have to be that? Why? Okay, this is true, but ladies and gentlemen, the value of the stock is the integral of the value of the flow from, you know, f of t dt, right? Here we're multiplying something of unit what? What is dt? It's a small unit of time. Multiplying something of unit time times something of unit x or a over t. Long day. A over t to get something of unit A. Does that make sense? So here we have a quantity that is measured in 1 unit, and the flow will always flows in, flows out, will always have the unit that can be expressed as the unit of the stock divided by t, divided by time. It's a amount of this per unit time. That's why it's a flow. Right? Okay. People do this all the time. They will do things like write x minus f. Nonsensical, semantically. What Benson will do, what AnyLogic will do is catch those sort of errors, which is a good thing because they are meaningless formulations, full of sound and fury, signifying nothing. But what it will not do is automatically convert them for us. It won't automatically convert days to years. Just because we have said this variable is measured in years, or this variable is measured in days, and yet our, it's no longer there, our units of time for a model we choose to be, AnyLogic doesn't allow years, does it? It doesn't allow you to choose that. It allows you to choose days. So imagine that units of our model as stated by selecting the model are years, are days rather, and suppose that we put a quantity which we state to be in years in our model, Alex. It's not going to automatically convert that in some magic way. If we put that in as a rate, 1 over this quantity in years, it will warn us if we ask it to do unit checking, but it won't actually correct it for us. It won't automatically say, oh, you're giving me a unit that's specified as 1 over year, I can convert it to 1 over day by dividing it by 365. It's not smart enough to do that, or by the days per year. Does that make sense to people? Okay, so the key thing that you need to do in this model is make sure, well, in any model, is to make sure that these places where you are actually specifying time delays, you're specifying rates, you're specifying inter-arrival times, those things need to be in consistent units in the model. And it's good practice to encode what those consistent units are up associated with the model properties. Make sense? Okay. Okay. That's for those who are still striving on the